Hi guys, thank you so much for joining up. We have Arun with us. Probably he's going to be taking the session for data structures algorithm. And yeah, welcome to the fifth day of Cipher Week. And I hope you're going to having an awesome session. Over to you, Arun.
Hi everyone. I hope everyone can hear me up. Yeah, audible. Let me just start on the screen part. Yeah. Hi everyone. I hope everyone can see and hear me up. Yeah. Okay. Cool. Okay. Before we actually start on with the session and actually start talking about data structures and algorithm and stuff like that, there are a few things which I want to be really clear about. Okay, let's first start with the introduction. First of all, my name is Arun. I'll be taking on with the session for your data structures and algorithm for today. I work as an iOS developer for Apple, and I'll be telling you a lot of my experiences. I'll be telling you a lot of other stuff. But as of now, there are a few things which I want to be really clear about before I actually start on with the session. Um, we are going to keep the session really a conversation with we're gonna keep it really crisp. I'm not gonna go around into a really different dimensions. I'm going to keep it really crisp. I need you guys to be really the conversation should go two way around. All right, so I should not only be the person who will be speaking up and ask you something. I really need an answer really prompt. Okay. We are going to keep this really informative. I'm going to tell you a lot of things which these companies demands. I'm also going to tell you a lot of different things related to algorithms, how you're going to keep it this way around. As of now, before we actually start on, is there anything that you want to tell me? Even we are going to keep this session a little longer because I want you guys to have a look on really different parts. Okay, so I'll be showing you a lot things. I hope you guys would be having. Okay, I would like to have Anurag and team with me, and I just hope if you guys can push the doubts from YouTube. Yeah, Anurag, Vani, anyone from the team. You guys, if you could. And okay, cool. All right, so should we start on? Shall we start? Anything that you want to ask, anything that you want to talk about, you can push your comments, push your any of the doubts that you have in the chat section. And if you're good to go, we can start on with the session. Shall we? Cool. I'm excited too. Yeah. Anything other than this? Anybody who wants to ask anything? Just give me a quick yes if you're ready. We can start on with the session. If you're ready, I'm ready. ML algo included? No, not for the session. It's completely basic data structures algorithm. I'll be telling you a few things here and there which these companies like Fang, asks you, and then we're gonna talk about a lot of different things. Okay. All right. So I'm just gonna stop the video so that I can share you up with the screen. Yeah, I'll be telling you how you could prepare DAO versus web development. I'm going to tell you each and everything. Okay, so I'm just going to break this down for you. Well, how we're going to do this is first we're going to talk about really data structure part. Then we're going to move ahead with algorithms part. Then we're going to talk about some competitive programming related things, which I'm going to tell you that if you're working on some data structures, how you're going to cover out different things and what are the different questions these Fang as a company asks you. All right, so this is what we're going to talk about. Right, I'm going to tell you different methodologies how you can prepare out for these interviews. What I'll be targeting right now is going to be Fang. I'm going to tell you the questions which these huge companies ask you, and you'd be good to go. All right, I'm going to tell you how you're going to prepare for all of this. Even if somebody is interested for going, let's say, for gate and stuff like that, we can have a talk about that. Apart from that, if we get time, I'm going to tell you a few other things as well. Okay, I'm just for the information purposes, may I know um, people who are comfortable with different languages? Just type in the language that you're comfortable in. Everyone. C++. No, language as in like programming language. C is Python. C Python. Okay. All right. All right. What I'm going to do in this session, I'm going to use Java. Okay. I'll be writing everything on Java. I'm also going to tell you how you're going to do the same stuff using C and C++ and stuff like that. And then I'm going to tell you really, really important stuff related to Java. Okay. If somebody who is really interested in Java, though I'm not a Java developer, but I love Java. I started, I dug really, really deep into Java. Anyone who wants to ask related to Java, most welcome. Please C++. Okay, so no bargaining on programming languages. See, again, programming language should not be a barrier because you guys would be a competitive programmer. And I'm hoping you guys will not have any issues with the program. Though I'm going to tell you that how you're going to write the same stuff on C and C++, that's completely fine. So I'm new to the world on this. Okay, no knowledge, please help me also. Not an issue. Okay, for the people who are really, really beginners, who are really, really like, I literally have no idea how to go into like data structures and stuff like that. Don't worry. I'm going to start from really, really scratch, gonna go around and build a application. I'm not gonna say it as an application, but data structure, and we are going to talk about some competitive programming related questions as well. Continue with Java. Is data structure essential for data science? Yeah, I'll say yes. Data structure, see, for any computer science programmer or be any coder, data structures is one of the basic things that everyone actually needs to know. If you're not good with data structures, I even cannot think of any domain for you, not even ML or AI and stuff like that. Right? So data structure is the foundation. If you know data structures, you can do anything. I'm being really, really serious. You're going to OS development. I myself is an OS developer, right? So you go into OS, you go into web development and stuff like that. Even if you talk about JavaScript completely is based on how you're going to loop around stuff, how you're going to do and stuff like this, right? So data structure is the foundation for any computer science developer, right? All right. So any other questions that you have so that we can move ahead, so that we can talk about agenda? Okay. So what I have thought as of now is linked to IoT. Yes, it is. Right. So what I've thought as of now for the session is all right. So how many of you are, if we are using C++ still? Yeah. See, again, programming language is not a barrier. You can write code anywhere. There's nothing hard and fast. All right. So what I've thought as of now is DS and Algo interrelated, read very interrelated. We're going to talk about that. I'm going to tell you how you can convert your algorithm into something really different. Okay. All right. So what I've thought as of now, a lot of people are really comfortable with linear data structures. What I've thought, should we go ahead and talk about nonlinear data structures if other people are okay? So please tell us from scratch. As a no problem, Manav. I'm going to start from really scratch. I'm going to take the session from the entire data structures part as it's quite lengthy. I'm going to pick onto one data structure as of now, and that data structure is going to be nonlinear part, right? Let's start with the basics of DS. Mihir, for the people who are really beginner, what I'm going to do, if we get time, we're going to talk about all the data structures and what are the pros and cons and when to use what data structure for any competitive programming stuff. That we can do at the very end. But what I've thought as of now is going to be really important for majority of the people, because a lot of people have a good idea about linear data structures. What I'm thinking as of now is to take starting from very basic nonlinear data structure. That is going to be tree as of now. But as we go around with the time, if we get time, we can implement a lot of other stuff. Can we have your contact info at the end of the session? Yeah. At the end of the session, I'm going to tell you how you can contact me up. If you have any issues, even after the session, I'll be more than happy to help you out. Don't worry about that. I'm going to share everything with you, but all I need is little responsiveness from your side. If you would be really responsible, I'll be more than happy to help you out. I'll be telling you a lot of good stuff. When you use data structure, please cover when to use what. Yeah, definitely. I'll tell you when to use what data structures. I'm definitely going to cover that out. So if you guys are ready, shall we start on with the session? Yeah. Shall we? Cool. So I'm really excited. Keep your focus out here. I'm going to tell you from really scratch. So even if the people who are really beginners, don't worry. I'm going to tell you each and every stuff. Resources. I'm going to share the resources as well. Don't worry. Don't worry. As of now, yeah, I'm going to cover recursion as well in the session. For the people who have no idea about recursion, don't worry. I'm going to tell you how you're going to write recursive codes and how you can debug all the recursive codes. That's also something that we're going to have a look on in the session, because trees is completely based on recursion. So we definitely do. We need to connect to the laptop. If you want to go around with me, if you want to code along with me, yes. If you do not want, if you just want to listen, handsets would be okay. All right, so let's go ahead. What I'm going to do is going to be gonna go onto my terminal. The first thing that you would be needing, if you're gonna go along with me, is you should have Java installed. So if you just type Java onto your terminal, you should see something like this, right? So this is going to tell you that yes, you have Java installed already. You can also do Java hyphen version. That's also fine. It's going to give you Java 8 because that's what I've installed. If you do not have Java, what you can do is basically download the JRE, install it up, go onto your terminal and type Java hyphen version. You should be able to see that up, right? So this is one thing that I've done. Apart from that, the application that I'd be using is going to be IntelliJ. Okay, so IntelliJ is one of the application. Yeah, sure, I'm going to do that. Don't worry. I'm going to do that. The application that I'm going to use is going to be IntelliJ IDEA. This again is a part of your Java JetBrains. JetBrains is the company which has founded it. This is the same stuff which you use in case of your Python as well. So Python, maybe you get an application called as I do not know, PyCharm. So PyCharm is also of JetBrains, and I guess JetBrains is sponsoring this whole event. So why not? Let's go ahead and use IntelliJ. Again, you are completely free to use any of the text editor that you want. If you want to work on Eclipse, more than happy. If you want to work on NetBeans, you can go with any of the text editor. The text editor that I'm going to use is going to be IntelliJ IDEA, right? Because I'm really comfortable with this. All right, so what I'm going to do is going to build a new project. And if I go along with this, again, for the people who have no idea what IntelliJ is, it's fine. This is really professional application. So professional web developer, I'm saying web developer, professional Java developers uses this, right? So what I'm going to do, I'm not interested in Groovy Kotlin. I was attending one of your sessions from yesterday, and you guys were having a conversation about Kotlin versus Java. And I was really amazed by you guys' responses. But I'm going to tell you what are the differences between Kotlin if we get time. And I'm also going to tell you that what are different things that you can do with Java. Uh, but that's going to keep it at the end of the session. But as of now, I'm going to make use of Java. You could see that the SDK that I'm using is 1.8, that's Java 8, right? And I'm going to create a Java application out of it. So I'm just going to click yes. And then I'm going to create one template out for me. I'm just going to say next. And the project name that I'm going to keep, let's keep this as CipherWeek. Okay, cool. Let's go ahead. Let's build something up. Now, this is one application that I'm building as of now. This is the layout. I'm going to create files inside this and stuff like that. But actually, before we actually start on and talk about what we're going to do as of in the session, how many of you have a good idea about trees? That's the first question that I want to ask. How many of you are comfortable with trees, or might have implemented trees before in the session, or anywhere in the course and stuff like that? Okay. All right, so let's talk about for the people who have literally no idea what trees are and how to implement that app. Like, who are literally blank, that you have never implemented. Trees, or binary tree or BST, we're going to talk about both of the stuff. BSTs and binary tree, I'm going to talk about both. Who have no idea, literally they're blank, they have no idea what this is. In terms of maths, not in terms of programming. Okay, I have little basic idea. All right, so majority of people have a little idea, but there are other few people who are literally blank. All right, so not an issue. Let's go around and talk about what we are going to study in the session. All right, so let's start with trees. All right, let's start with trees. Then we're going to jump into BST and stuff like that. All right, cool. All right, so welcome, and we're going to talk about trees now. Okay, now everyone, just stop what you're doing and just stay focused. Everyone is here with me. Just give me a quick yes so that we can start on with the trees part and start talking about trees. Mm-hmm. Cool, great. We're going to keep it really, really informative and two-way conversation. So when I ask you to comment up, just be really quick with the responses. Okay, cool. What we're going to talk about is trees. Now, before we actually start on with trees and start talking about what trees is, first of all, we should be very clear about why do we need trees. Okay, there are really, really complex situations and really, really complex problems where you have to really think about the data structure which is needed to be used in order to play around with the question or play around with a sample problem statement where you have to build something out of it, right? Just try and understand what I'm saying. It's a hierarchical data representation, not exactly. First you should be really, really clear about why do you need trees. So let's start on with very easy task. I'm just going to go on to OneNote. I'm going to tell you a few different things. Okay, now what do we have and what we used to have was basically you have a lot of data structures, right? You have a lot of data structures. uh, so you have a lot of data structures. Okay, now typically when you say data structures, the first thing that any noob actually start on with is array, right? You have arrays, right? You actually start on with the coding when you used to talk about arrays, right? What typically an array is basically a collection of similar kind of like data types. If you're talking about integers, it's going to be a collection of integers. If it's a character, it's going to be a whole collection of characters or stuff like that. So you pick on any data type and you can create a collection out of it, and you can create an array. But there are few things that you actually need to keep in mind if you're working on array. As Jayesh said, it's a contiguous memory stage, right? When you say it's going to be contiguous, what do you actually mean? If let's say if I'm creating an integer type data and let's say I'm going to keep the size as 5, what this typically means that in the stack memory somehow it's going to create 5 memory locations for me, but these memory locations are going to be stored in a way depending upon the size of the data type that you're going to use. If I'm talking about Java typically takes 4 bytes for storing up your integer type data type. Okay, so if let's say if I'm saying I'm going to create an array of the length 5, that means if let's suppose if my memory is starting from 100, it's going to go like this: 104, 108, 116, 12, and then 16. Yeah, yeah. So this is how the memory is going to get segregated. Now, there is an issue with this. What is the issue? Let's say if you're working in, let's say, a whole old age era where you had very limited storage. Now, in that case, what you actually need to do or what you have is basically a data structure or a data type where you're saying that if let's suppose if I'm creating a collection out of it, and what do I have is the memory being organized in such a way that you need memory in a contiguous manner. If you do not have memory in the contiguous manner, you're stuck. Just yes or no. Yeah, this is going to be an issue. If let's suppose if I'm saying that I have few little memory left in the system, how am I going to do that then? Right? I won't be having contiguous memory then. What we came along with this was basically called as array list. Anyone who have any idea about array list? Anyone who has any idea about array list? Okay, one. Okay, how many of you have never ever heard about array lists? Anyone who has never heard about array lists? Okay. Uh, yeah, it's kind of like a vector in C and C++, but it's array list in case. Okay, so if you're working on Java, yeah, it's kind of like list in Python, but yeah, it works exactly the same way, where you can create dynamic arrays out of it, right? What do you have when you create an array? You actually cannot remove the data out from the array. You can manipulate the data definitely, but once it's done as 5, when you have said that your array is going to be of the length 5, then you cannot go around and manipulate that up, right? But in case of your array list or in case of your vectors in C and C++, you can definitely can do around a lot of stuff. You can insert data, you can remove data, you can basically manipulate data in any which way that you want, right? But again, this does not solve the problem for your memory location. Though it's really, really flexible, it's really, really cool to use array lists and stuff like that. But again, it does not solve the problem statement where I'm saying that the array is contiguous memory. And if let's suppose if I'm working on a small bulk of memory, I will somewhere get stuck. So is the case with array lists as well. And so is the case with lists that you talk about in Python, right? So this is still the problem. The problem still remains same. Then we said that we are going to talk about one data structures, what I'm calling this as a linked list. Now, I'm not going to talk about stacks and queues as of now. If you want to delete the second position from the big array, then it fails. Yeah, it does. But if you're working on array list, you can definitely can delete any data that you want. You can insert any data that you want in between and stuff like that. You can override, you can overrule, and stuff like this. Okay, so array list is really flexible in terms of when you talk about manipulation and operations in arrays. Okay, now what we came out as a solution as of for now is talking about linked list. Sorry, how many of you actually know what linked lists are? Linked lists. Yeah. So linked list, I'm not going to go really deep into linked list and talk about that. But linked list is basically a concept where you're saying, okay, fine, I cannot use contiguous memory locations. But what I'm going to do is basically dig out different memories from different positions and I'm going to link them up all around. Right. So what do you have is basically this memory location. Let's say I'm going to call this M1. Let's gonna call this as M2. Let's gonna call this as M3. And what do you have basically? These are connected to each other. So this M1 is basically pointing to M2 and M2 in turn is pointing to M3. So if we look at it, it's gonna look like a chain. Though there is no connection between that where this data is stored in the memory. It could be 100, this could be, let's say 115, this could be entirely different, let's say 1004 and stuff like this. So internally what happens, you use pointers inside this, as Arvind said. So you use pointer in order to point towards the next memory location that you have. So what do? You pick out different memory locations from your memory heap. And what do? You basically link them up together and try to create a chain out of it. And then you call this as a linked list, a list which is linked together. Makes sense, right? This makes sense. Yeah. I hope that this little part is clear to everyone. Now we're going to talk about that why do we actually need trees? This is the whole picture. This is the whole scenario that everyone knows, that starting from array, ending at a linked list. This is the whole stuff that actually goes around. Yeah. So should we start talking about trees? That why do we actually need trees? Yeah. Should we go ahead with that? Should we start talking about trees then? Yeah. Okay. Now, what do we have here is basically a chain that which I just explained you up, saying that okay, if you have different memory locations, what you can do is basically chain around with them, and you can say that it's going to create a link between different memory locations, and this is going to solve your problem map. But uh, this will solve the problem. But let's talk about one small little thing. Let's say I have a linked list. Okay, let's talk about that. Let's say I want a linked list, and this is the linked list. Let's say I call this as 200. This is 100, and let's say this is how it's gonna look like. This is 200. This is going to be 30. Let's say I'm just gonna call this null, and this is going to be 300, and this is your head pointer, right? So head is basically where your linked list starts from, right? So this is your head, this is the first node of your linked list, and this is how your linked list is going to look like. Okay, let's assume. Now let's say I right now have three data. Let's say if I had a lot of data inside this, like something like this, for let's say null and stuff like this. Okay, I had a huge linked list. Let's say I wanted to search something from the linked list. Just imagine if, let's suppose, you have a bulk of data, can you actually go around and loop around all the elements and search around it? What you basically will have to do, you'll have to start from the head, go at the end of the linked list, and if you're searching something up in your linked list, is it going to be easy or is it going to be time consuming? Just think about it and tell me. Is it going to be time consuming or is it going to be easy? Definitely it's going to be time consuming, right? Now the end that I'm talking about, or the size that I'm talking about, I'm not just going to say that okay fine, the data is really small. No, the data is going to be really huge. If let's suppose you have thousands and millions of data and you're storing it inside a linked list, you should have to be very clear about that. Searching that data in the linked list is going to be really time consuming. Why? Because you'll have to go around with each and every node and will have to search for the data that you're looking for. Yes or no? Anyone who has any doubts related to this, just give me a quick yes or no. Yeah, it's kind of like a linear search where you have to go around onto every node and think that if this is the data that I'm looking for. I hope everyone is clear till there. Just give me a quick yes so that we can talk about. Yeah. Now, this problem statement of actually searching data inside a huge bulk of pile of data is really not convenient if you're talking about data, this linked list, right? If you start the search from where we want to, can't we start this? Okay, how would you? Okay, Acer, I don't know what your name is, Acer. If let's suppose if I ask you, I wanted to search 30, do I actually have an idea about the linked list and stuff like this, that I actually need the data 30? How would I know that data 30 is there in the linked list or not? I'm not sure about it, right? I'm getting a really sample data, and that sample data I need to search onto something. I have literally no idea if that data is already available there or not. What I have to do is basically pick around onto all and every data, and I will have to figure out that if that data is available in the set or not. If location is given, see, if you already know the location, there is no point of searching that data out. Just, does this make sense what I'm trying to say? If you already know the location, is there any point of searching the data out from the set? सोच के देखो. Yeah. Why to search then? Okay, you go around onto Netflix and you have a huge database of movies out there. Why do you search a movie? Can't you just scroll around and see where your movie is? Arvind, just think about it. Yeah. Now again, Jayesh, now I'm going to talk about this. Sorted linked list is also going to be really time consuming. If you're going to go around onto sorting out your linked list, this is going to be really time consuming process. Sometimes it even goes to n square. It's not easy. It's definitely not easy. If you're saying that I'm going to sort my linked list up, it's going to be really time consuming. Yeah. It's going to take more time as compared to n square. It's definitely not easy. Now, is it making sense what I'm trying to say? Guys, can't we use binary search? Okay, how are you going to use binary search in this particular case? Just think about it. Your data is not sorted. You have no sorted data, but you are trying to diverge up your data into two different parts, and you literally have no idea where to go. It's not an array. It's definitely not an array. Even if you talk about this, if you're saying, Ki, I want to use binary search knows where your data is. Yeah. In that particular case, you cannot do something called as binary search because the data is random. You'll have to arrange the data first of all. There is no arrangement of data. Now, guys, is it making sense now? Is the bigger picture clear that why we cannot do something like this? If you want to search something out, you definitely cannot make use of arrays. You definitely cannot make use of array lists. You definitely cannot make use of something called as linked lists and stuff like that, right? So this is the whole idea. If now this is the point where everyone actually need to understand. Uh, what do you have here is when you're trying to write a code or a program where you feel like you will have to search the data eventually. In that particular, you are not asking questions. We are giving reasons. Uh, yeah, that's what I'm saying. I'm countering up your reasons. That's what is happening right now. It's a two-way conversation that we're doing, right? Don't take it otherwise. It's not that I'm saying that you're saying wrong. It's good that you're keeping up your points, but I'm figuring that out, that if what happens if something happens like this. Yeah, guys, if you're good to go till here, just give me a quick yes so that we can start ahead. Yeah. Now, what are we going to do? Because what do we have is basically really not sufficient, right? We're talking about arrays, array list, and linked list and stuff like this. But this is really not sufficient if I'm saying that I need to search something up or manipulate the data. Manipulation and searching the data is really not easy when you talk about data structures like linked list. Now, what could be done is basically we can diverge the data into different sections in different ways. Now, if you just talk about linked list, your linked list looks something like this. That it's a node, it's a memory location which is linked to another memory location. So this is the bigger picture of linked list. This is how your linked list looks like. This is one of the reasons this is called as linear data structure. Linear means in a line, right? What could be done is basically introduce something called as nonlinear data structure. Now your nonlinear data structure is going to look something like this. Yeah. This is how your nonlinear, and you could have multiple other things outside of here, right? So this is how your nonlinear data structure is going to look like. Okay, so this is the nonlinear data structure part. Now, nonlinear saying that you do not have data in a sequence. You are rather creating tree like a structure where one node is handling, or one particular memory location is keeping the pointers for different other memory locations. So your node or your data or your memory location is not actually pointing towards one specific location, rather to different memory locations altogether. We no need to traverse all the data. Definitely, that's the case that we're talking about, where we are saying that the problem statement in case of your linked list was we were basically traversing the whole data in order to search and to manipulate the data. But in case of your nonlinear data structure, you do not need to actually go around onto all the data. You do not need to traverse all the data. Whatever data that is useful for you, you're going to pick that up, do the operations, and you're done, right? So this is how the trees as a data structures comes into picture. Let's talk about that. Then we're going to talk how we're going to implement that. All right. So what are trees? So what we're talking about that, what are trees? Unlike of arrays and linked lists and stacks and queues, which are basically linear data structure, you have to think of the other way around, where you're saying you will have a data which is going to be hierarchical representation of your data, right? You're going to build something, you have to build a data structure which is not going to be linear, it's going to be hierarchical in the structure, right? Generally in the data structure, a binary tree is called as a binary tree. Really, really important. Anyone in the session who have any idea about a data structure called as forest? Anyone who has ever heard about forest? No. Okay, so just a quick takeaway for the people who are interested into this, not disconnected graph. Uh, Forest is a different data structure. If you go into higher studies like MTech and stuff, you're gonna go and go around and implement forest. So forest is basically a next generation of your binary tree. So it's basically what? It's basically like one node can basically go around and have multiple children rather than just having two children, where that's what your binary tree does. So binary tree basically has what? It's going to contain memory location of two other memory locations. This is what happens, right? But in case of your forest, that's not the case all the time. One node can basically go around and point towards multiple other memory locations as well. So this is the case when you talk about that, what forest is. So forest is going to be something like this. When we talk about trees, when you talk about the companies and when you sit for the placements, when they say tree, they're basically saying binary tree or binary search tree, right? Binary. Okay, so now let's talk about what binary trees are. So binary tree is basically a special type of a data structure, which is for storage purposes only, in which you store a data in a hierarchical order. Now, how does this look like? This looks really, really easy. This looks something like this. So what are you going to have? Your binary tree is going to look something like this. If you have a binary tree, your binary tree is going to look something like this. This is your binary tree. So there is going to be node 1, and this node 1 will basically have two memory locations altogether for node 2 and for node 3. This is how it's going to look like with particular properties. No, Jayesh, you're taking the road on a different side. Just hold on to this question for a while. I'm going to tell you that what you were saying and why is it not correct. Okay, this is really, really not correct. Why? I'm going to tell you that. But what do we have? A node with two different other memory locations, right? Sequence of particular property does not really matter. But as of now, we're going to talk about that what is really different in case of your binary tree and binary search tree. Okay, let's not jump ahead onto the lead. Okay, so this is for storage purposes. What you're going to do is going to create one memory location which is going to hold two other memory locations for you as well, right? They have their own utility, they have their own functionalities, and how do you use this? We're going to talk about that. Okay, now this is how your binary tree looks like. Your binary tree is having one small little structure, which structure is called as node. This node contains the data that you have, and two different memory locations for the left child and for the right child. So B as a data is going to be the left of A, and C as a data is going to be the right of A. Okay. Similarly, if I talk about D, what D is basically the left child of B. And if you just have a look on the right child of B, there is no right child for B, right? So this is how we are arranging the data. If I talk about data C, in case of your data C, E is going to be the left of C and F is going to be the left of or right of C. But in case of your E and F, you could see two crosses out there saying E is a node which does not have any children, neither left nor right. And these kind of like nodes which do not have children is called as, can we have this PPT? Surely you can have that up, right? So I'm going to give this PPT to CipherSchools and CipherSchools is going to do needful. Yeah, correct. As Rahul said, these nodes which does not have any children are basically called as leaf nodes, right? These are leaf nodes. Okay. Is this tree or BST? This is just a tree. This is no BST. It's just a tree. Yeah. Now, terminologies, I'm not going to waste time onto this, but the more we're going to code, abhi ruk jao, we are going to take baby steps. We're starting from scratch, right? You have no idea how to code binary tree. How are you going to talk about BSTs as of now? I'm going to take each and everything on account. Don't worry. Everything would be taught in the section. Don't worry. Don't worry. Everything would be covered out, right? So these terminologies, I'm going to skip that around. But the moment we're going to code something up, these terminologies would be clear to everyone. Okay, cool. So this is how it's gonna look like. This is the whole bigger picture, and let's go around and code this up, right? Let's not waste time. Let's go around and code that up. Now, what do we have and what we're going to do is basically going to make this small little structure that you can see out here, where you have a binary tree, and this binary tree basically have a structure somewhat called as node, which basically have some data, and you have a left child and the right child. And these child, the left child and the right child basically are nothing but memory locations for other data in order to make this look like a tree. So if you're ready, just give me a yes so that we can start ahead with the coding part. Yeah, shall we? All right, cool. So let's go ahead and do the needful. Okay, for the people who are not from the Java background might feel a little weird, but it's completely fine. I'm going to tell you how you're going to create the same structure out if you're working on C and C++. Okay, don't feel lost. If you feel lost, just ask your doubt. I'll be more than happy to help you up. Got it? Guys, got it? Okay, I'm going to use few things in Java, and then I'm going to tell you you can do the same stuff using C and C++. Okay, now let's say I have the source. This is the main file, right? So I'm not going to make use of it. I'm just going to go around and create a new class. Oh, sorry. I selected Kotlin. So I'm going to go new Java class. I don't know any program. It's fine. I'm going to tell you how you're going to know this program. It's fine. And I'm going to call this binary tree as of now. Okay. What I'm building, is there any option in C or Python? I'm going to tell you how you're going to create this. Don't worry. Don't worry. It's fine. It's fine. I'm going to tell you how you're going to code this around. Okay. Now, what I'm doing is basically creating a class called as binary tree. What you are going to do is basically create a C file called as binary tree, right? So there are concept of classes, concept of object-oriented programming in case of your Java. So which is the tool that you're using right now? This is called as IntelliJ IDEA. This is the text editor that I'm using right now. You can go around and install. You can also use Eclipse. You can also use NetBeans. You can use any of the things that you want. Text editor is not a problem. Okay, do you have any idea how you actually compile your stuff in case of your Java? If you have no idea, I can tell you about that. Even if you do not have a text editor, you can still do the needful. Yeah, you can do the terminals part. You can just create a .java class. You can just go to terminal, say Java C, the name. Yeah, Java C and the name of the file. Click enter. It's going to create, it's going to compile the file. It's going to create a .class file. You can run that .class file and do the needful. So even if you do not have a text editor, it's fine. You can go around with your terminal and do the needful. Okay. So let's not waste time, guys. Should we start? Okay. Now, what I was telling you is that here I'm making use of classes because I'm working on Java. If you're working on C and C++, you can go around and create the file called as binary tree. It's completely fine. Okay. Uh, Anyone who's feeling lost as of now, I have not started anything. I have not coded even a single line. If anyone is feeling lost right now, just let me know. Anyone. Okay, so if you're good to go, just give me a quick yes, because I do not want to waste time. I want to give you a lot of different things in the session. Okay, cool. Now, what I'm doing is basically creating a binary tree. It's fine. मैं basic से कराऊंगा, कुछ hard and fast कुछ नहीं होगा यहाँ पे. These terms in the chat are making me confused. It's fine. Don't look at the chats. Just listen to me. Okay. What I'm doing is creating a binary tree. And this binary tree, I'm calling this as a class. What this class is going to do? No idea. We're going to talk about that. All right. But I've just created up this class called as binary tree. And inside this, I'm going to write all the code, which is going to make a binary tree. Right. So there would be a code that is going to create binary tree. Okay. Now, as I said, there is a thing that you actually need to do before you actually go around and build your own tree. What is that? The thing that you have is basically here. If you just have a look on this, in this case, if you talk about a tree, what is your tree basically doing? I showed you this. Your tree basically have a data. You have some data. That data is stored. But along with this data, what do you have to keep is basically the memory locations for your left child and the memory location for your right child as well. Yeah. Guys, if I talk about this one small little memory location, can you just figure this out? If I'm saying LDR, does this make sense? What is L, what is D, and what is R? Yeah. Others? Everyone, I'm asking it to everyone. Does this make sense? Yeah. Now, what you have to do is basically give the structure of a node before you actually go around and build your application or build the tree. So what you're going to do is going to, describe the structure of the node. What you're going to do, you're going to, just one second. What you're going to do is going to define the structure of the node. That's what you're going to do, right? How are you going to do that? If you're working on C and C++, you're going to do something like this. If you're going to say struct node, and then you're going to create the structure of the node. If you're working on C and C++, right? I am working on a programming language, which is object-oriented programming. So definitely what I'm going to do is going to create a class out of it. I'm going to call this as node. Does this make sense? Yeah. What you have to do is define the structure of the node first. If you're working on C and C++, you're going to write struct node and create the structure. If you're working on any object-oriented programming, you're going to create a class. If you're working on Python, you'll have to create a class for your node. Guys, any object-oriented programming, go for class node. If you're working on programming languages like Objective-C and C and C++ and stuff like that, you're going to create a structure out of it. Yeah. Now, the structure has what inside it? What do you have in the structure? If you just have a look around onto this node, what do you have in the structure? Basically, a left child, a right child, and a data. Okay. What do you have? A pointer to the left child, a pointer to the right child, and the data itself. Now, the type of the data typically depends on you. I'm going to take integer. You can go around and take string. You can go around and take float and whatever you want, right? So I'm just going to call this, what this node is going to contain. It's going to contain a data. And apart from that, what it's going to contain is the location for first and last child. Oh, sorry, first and last. Why I'm calling this the first and last? It's going to be left and right. Sorry. Okay. Now, everyone, just pay attention. A lot of people generally get confused up here. Everyone is here with me. If I ask you one small little simple question, anyone who would be having any idea, just give me a yes or no. Do you know that whether Java supports pointers or not? Anyone? No. So a lot of people are saying that, hey, Java does not support pointers. It does not. And it definitely does not. Now, the point here is that I need to store a memory location for my left and right child. What should I do? Now, this is a dilemma. Get the problem statement first clear onto your heads. Is the problem statement clear that what I'm talking about? What do I need to do is basically link this particular node to a left and right child, where I have to give the pointer to the left and right, right? But what I know that Java does not basically supports pointers. Now, what do I need to do? Is the problem statement clear to everyone? Guys, is the problem statement clear? Yeah. Now, what I'm going to do is going to give the location for left and right child, and just have a look at how I'm going to do this. I'm going to say node left, comma, right. Just figure this out, what I'm saying. I said I'm going to have two memory locations called as left and right, and they would be of the type node. Does this make sense to anyone? And if this is really confusing for you, just give me a no. If you're confused, give me a no. Okay. If you're good to go, just give me a yes. If you understood this part, just give me a yes in CPP. Okay. So just figure this out. What I'm trying to explain you up here is basically really, really easy. Isko zara dhyan se samjho. Just try and understand what I'm saying. If let's say if I do something like in CPP, we can use pointers. Yeah, definitely. If you're going to use this, so what you're going to do is basically going to create pointer out of it. You're going to say int pointer left and a pointer for right. So you're going to create two pointers out of it. But of course, you know that you do not have pointers. So what I'm going to do is basically going to say node type left and node type right. Okay. And this is going to do what? It's going to create okay, listen to me very carefully. It's going to create one memory location for you, but the type of the memory location is going to be node. What does this mean? As of now, let's keep this question for a hold. I'm going to explain you this up in a little while. But as of now, I have created memory location called as left and right. Okay. Abhi filhal ke liye, let's keep it on a hold because I want to show this programmatically that what's happening behind the scenes. Okay. But a lot of people have a confusion on this. If you're good to go, just still here, just if you could move ahead, just give me a quick yes. Shall we? Okay. Now what I'm going to do, I'm going to create a constructor for the class. Now, if for the people who do not have any idea about constructors, so constructor is basically one small little thing that you have to create before you actually initialize the object. Okay. Initialization happens when you go and create the object for that particular class, right? So that there is a class called as node. So whenever you're going to create the object for this class, you will have to create the constructor. What does a constructor is? This constructor is basically a kind of like a function which has the exact same name as that of the class, right? So name of the class is node. So the constructor name is also going to remain the same. And I'm going to make this constructor as a parameterized constructor. I'm just going to keep call this int, let's say data. Int data. I'm going to call this dot data equals data. And I'm going to say this dot left equals this dot right equals null. Now what I have done, just try and understand this part. What I've done and what I'm trying to do, just try and understand this up. Now, if let's say, if I want to, can I not annotate on the screen? You're writing void in front of node. I'm going to wait a second. If I can annotate on the screen, no, I cannot annotate on the screen. Fine then. Chalo. Anyways, what I could do is, if this allows me to do something like that, but I won't be able to do the same stuff with that. But anyways, chalo, koi baat nahi, kar lete hain. Okay. Now, what do we have and what we're going to do? Just try and understand the part. What I've written out there is basically a class node, which contains an integer type data and a node type called as left and right. Just try and understand. Agar ye samajh mein aa jayega, trees is nothing in front of you. I'm being really serious. Just try and understand the structure. Everything is going to be fine. Then what you have is basically I've created up a constructor, gonna call this as node, and you're saying int key, and you're passing something inside this, and you're saying this dot key or this dot data, or just gonna call this data. This dot data equals data. And I'm gonna call this dot left equals this dot write equals null. Now just try and understand. So if you're talking about constructors do not have return type. They do not have return, not even void, right? So they do not have return type. They only contain parameters. They do not have return type, not even void. Got it? So this is how you can think that this is going to be a constructor. Constructor has the same name as that of the class, does not have a return type. Keep that in mind. Okay. Now, when I'm going to create a node, how my node is going to look like. Everyone is here, just pay attention. Everyone is here, just give me a quick yes if you're here. Quick. Just understand this part. This part is going to be really important. If you actually understand this part, the whole session is going to be really easy for you. Now, just understand this. What happens if you're saying I'm going to create a node? If I go around and do something like node, new node equals new node, and I pass, let's say 10. This is where I'm creating a thing called as new node. I'm creating the object of the type class called as node, which is this class. And I'm creating the object. This is the object which I'm creating. The name of the object is new node. And I'm saying new, and I'm calling a function, which basically is a constructor. This is your constructor. And in the constructor, you are passing 10, which is this integer key, right? What is this line going to do for you? This line is basically going to create a node for you. This node is going to look something like this. The data that you have passed is going to get inside to this constructor. Now, this is the constructor which is getting called. Where is the definition for the constructor? This is the definition for your constructor, where you're saying node int key, and the key that you have passed is 10. And then you say this dot data equals data. The data part in the node is going to be the data which your user is passing. And right now the data is 10. So what do you have? You have the data as 10. And then what you do is basically keep the left and the right part as null. This is what I'm trying to do. That every time I'm going to create a node, I'm going to copy the data and keep the left and right as null. Does this make sense? Everyone? Other people? Does this make sense? If I'm saying, if I'm going to write something called as node new node equals new node, data should replace the key. Yeah, definitely. Yeah, got it? Now, so this is what I've written out here. If you just have a look out here, this is what I've written. I'm saying every time I'm going to create a node, this is what is going to happen. I'm going to have a data, I'm going to have a left and right, and every time there is an object, every time there is a constructor being called, every time there is an object being created, I'm going to paste the data in the data part, and the left and the right of this particular node is going to be null as of now. The rest, what's going to happen, I have no idea. But this is the thing, that every time I'm going to create a node, this is how it's going to look like. The left and the right part of the node is going to be null every time. Okay, should we go ahead? Should we talk about other things as well now? Chale aage? Cool. Now, what I'm going to do, I'm going to create a binary tree. Okay, I'm going to create a binary tree out of this structure of the node. Okay, how am I going to do that? Before I actually go around and code around for binary tree, one thing that I want to ask for everyone. Whenever you actually study about linked list, there is something which you call this as head. What is head? When you say that you have a linked list, one thing that is really, really common with every linked list is going to be the head of the linked list. What is the head? Why do you need head? It's a starting pointer, right? It's the start of your linked list. This is where your linked list starts from, right? It stores, yeah, as Rahul said, it stores the address of the starting node. Yeah. Similarly, when you talk about binary tree or binary search tree or any of the trees for that matter, what you have is basically called as root. And what is the root? This root is the starting point of the tree. This is going to be the starting point of the tree, right? For that, what I'm going to do, I'm going to create a root. And this root is again going to be of the type node. This is what I've done. Okay, how this is good, this root is going to be node, I'm going to show it in a little while, but does this make sense? So what I've done, I've created up a starting of your tree. I'm going to call this as root, and this root is of the type node. Make sense? If yes, just give me a quick yes so that we can move ahead. Yeah, cool. Now this is the root, and now what I'm going to do is going to go around and insert data inside this, right? Now, one thing that I'm also going to do is going to say binary tree, just try and understand the concept out here. And I'm just going to say this, or maybe not, okay, just going to say this dot root equals null. Now, what does this do? And what does this mean? Just try and understand. The node actually means, can you come again with what node actually means? This node means, okay, I'm going to keep it really easy. Okay, just try and understand this. Okay, let's say Parv, Arvind, for the people who didn't get why I'm writing node in front of root, just answer me the simple question. If let's suppose I want to create integer type data called as number, how am I going to do that? What is the code which actually goes around? I want a variable called as num, and it should be of the type no. It should be of the type integer. How are you gonna write that? You're gonna write something like int num, I guess, if I'm not wrong. Yeah. If let's suppose if you want something called a string, what you're going to do is basically write string name. Yeah. This is what you do. So it's the data type and the name of the variable that you've given out here. Right now, what's happening? You have created a class called as node, and you're mentioning this node as a type of the data. So what is happening? You're creating a root of the type node, and here you can understand node as a complex data type that you're creating in case of your Java, right? So you can call this class node as a complex data type. So what I'm doing is basically calling a root which is of the type node. Does this make sense now? So this root will have all the functionality. It will have a data, it will have a left, it's gonna have a right. Guys, yes or no? Other people? Everyone? Does this make sense? Cool. Okay. So what I'm doing, I'm creating a root which is of the type node, which is going to point towards the starting of the tree. Okay, this is what I'm doing. And the next thing that I'm doing is this. I'm creating a constructor for your binary tree and saying that, hey, every time I'll be creating a binary tree, a new binary tree, whenever the object of this class, this binary tree class is going to get created, I want my root to point nowhere, right? By default, it's not going to be null, but the moment you're going to create the object for your binary tree, then you are initializing this and saying that my root is not going to point anywhere because this is the fresh tree that I'm creating right now. Got it? Guys, got it? ये मैंने क्या लिखा है कंस्ट्रक्टर के अंदर? Everyone, I'm asking it to everyone. If everyone is okay, just give me a quick yes so that we can move ahead. Right? So what I'm saying that every time I'm going to create the object for my binary tree, what's going to happen is basically I'm going to initialize the root as null. Okay? Why? Because I need a fresh tree to start on from. Okay? Cool. Now, the next thing that I'm going to talk about right now is not going to talk about how you're going to store anything inside this. Let's say somehow we store the data inside a binary tree. Now we have to see that data, right? You have to display that data. And for displaying the data for a tree is little vague or little complex in that particular matter, right? What is going to happen is you are thinking of to create a function called as display, where you can go around and display the data in the tree. Now, let's talk about the possibilities that could happen, right? Let's say, what do you have? I'm going to get rid of it. Let's say you have a tree which looks something like this. Say you have 10, you have 20, you have 30, you have 40, you have 50. This is how it looks like. right? So the node 10 has two children called as 20 and 30. 20 as a node has two children called as 40 and 50, right? What do you think? How can I display the tree so that it could be easily understandable for the people who knows tree? Just think about it. How do you think that this could be displayed to the people? Think about it. This is a tree, and I want to display this tree to my user. If let's suppose if I had linked list, how I used to display the linked list. This is how I used to display the linked list, right? I used to do something like this. Let's say I have 40, and how you used to do was you used to display 10, 20, 30, 40. Why? Because it's linear, right? In case of tree, this is definitely not linear. This is 2D kind of like a structure which has a starting point which is basically pointing towards two other different things. What do you think? What do you think is a solution could be the possible solution? Think about it. Even if the solution is wrong, it's fine. But I need solution out of it. 10, 20, 40, 50, 30. Not good enough. Okay, for the people who know traversal, who knows in order, pre-order, post-order, I'm not talking about them. For the people who have no idea कि अभी क्या कर सकते हैं हम लोग. Just think about it. This is a problem, right? Yes or no? This is a problem, isn't this? This is a problem. That how we're going to display the tree. This is literally a problem. Yeah. Now, there are basically 4 solutions for this. There are 4 solutions in order to display a tree. If you have a tree, there are 4 solutions for this. Yeah, this could be one of the possible solutions. One solution is either you go, which you call this as level wise order, or level order traversal. There is one traversal which you call this as a level order traversal. Second is something which you call this as in order traversal. Then you have something which you call this as pre-order traversal, and there is something which you call this as post-order traversal. Now, before I actually go around and talk about orders, let's talk about how have we created these orders and what does these order mean, right? Just array representation with children into 2 into and 2x plus 1. Got it. But abhi ke liye, this is, Param, what you're saying is true for binary search tree, but this is not always applicable for binary tree. This is not applicable for binary tree all the time. I'm going to tell you why. Param, is question ko na, just keep it for an hold. I'm going to tell you that why the thing that you're saying is 2x and 2x plus 1 and 2x plus 2 is not actually capable in case of your binary tree. I'm going to show you this practically, don't worry. But as of now, these are the 4 possible solutions that I can think of. Either what I can do is basically print out something like this, where I'm saying this is level 1. And the first data is going to be my level 1. This is the first thing that I display. This is going to be the second thing that I display. And this thing is going to be the third thing that I display. This is what you call this as level order traversal. Yeah, this could be one possible solution. Yes or no? Can this be a one possible solution? That I'm going to display my data to the user, something like this. Yeah. Next thing that we have is called as in order traversal. In order means, now for the people who have idea about in order, just still listen to me. Why? Because you generally get confused with this. In order means, in means the parent. Kya bola? This is going to be my root, right? This is where I'm going to start because I know that root is the thing where I'm going to start from, right? So what I have is a root. I'm going to go around and display the data. But first thing that I'm going to display is definitely going to be root because that's where my tree basically starts from. This is the first node which I'm going to start with, right? So what do you say? You say that, hey, when I say in order means that my node should be in between of the left and right child. This is what I mean with in order traversal. In order means that what I'm going to do, I'm going to pick a node. And in that case of the node, what I'm going to do is going to display the left first, then I'm going to display myself, and then I'm going to display the right child for that. Got it? Does this in order make sense? So the parent or the node is in between of left and right. That's why it's called as in order traversal, right? In case of your pre-order, your node is going to start first, then your left and right child are going to appear. And in the third case or in the last case, what's going to happen? Your left and right have might already got appeared, but your node is going to appear at the end. Does this make sense? Guys, does this make sense? Everyone, I'm asking this to everyone who's sitting in the session right now. Yeah, other people, just 4-5 people. Okay, cool. Now let's start with easy part, then we're going to move ahead. Okay, so keep that in mind. These are the orders which we are going to implement as of now. We are really running short on time, guys. Let's do it really quick because I want to give you a lot of things. Yeah, I'm going to give you the outputs, but as of now what I'm going to do, अभी छोटा सा ट्री लेते हैं और इसको समझने की कोशिश करते हैं that what's actually going. If you think about this small little tree out here, and now what I'm going to do, I'm going to tell you about in order, pre-order, and post order. Okay, so in order is D, L, and R, right? So what's going to happen if this is the node? What I'm going to do, I'm going to display my left first. So 20 is the left, which is gonna get displayed. Then I'm going to display myself, which is the data right now, which is typically 10. And then the right part of the tree, which is going to be 30. But in case of my pre-order, pre-order says I'm going to display myself first, then I'm going to display my left, then I'm going to display my right. This is going to look something like 10, 20, and 30. Okay. And then if I talk about post-order, what I'm going to do and what I'm going to talk about is first I'm going to do L, then I'm going to do R, then I'm going to display myself. It's going to look like 20, which is left, 30, which is right, and then 10, which is the node itself. This is how it's going to look like. Now, if I take this tree into account, let's talk about this. Now, if I talk about in order traversal, the in order traversal is going to look something like this. Guys, just pay attention. This is really important. Just pay attention out here. Everyone is here. Just try and listen to me. This is how you're going to understand the recursion part. I'm going to do a lot of recursion inside this. And this recursion might seem a little vague to a lot of people. But I'm going to explain the whole recursion part. Don't worry, we're going to have a look on it. Is everyone ready? If you're ready, just give me a yes so that we can move ahead. Cool. Now, see guys, what's going to happen? What I'm going to do, I'm going to build an in-order traversal for this particular whole stuff, this whole big tree. Where I'm going to start from, I'm going to start from the root. And then I'm going to go ahead and display all the data that I have, right? Now, how I'm going to do that? I'm going to say in order traversal, and in this in order traversal, I'm going to start with the root. Okay. Now this root is also going to have LDR, 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 LDR. Why I'm writing this up? This is going to make a lot of sense as of now. Now let's say this is where I'm starting from. Everyone, just listen. Let's say this is where I'm starting from. Wait a second. This is wrong. This is totally wrong. Just listen. I say this is where I'm going to start from. This says, okay, I'm going to the left of my tree and then I'm going to display this. So it comes to 20. And then in 20, you also have LDR. It says, first I'm going to go onto my left, then I'm going to go onto myself, and then I'm going to go onto my right. But 20 already has its left part, so it cannot display itself until and unless the left of 20 is not displayed. So it comes to the left of 20. Then it's going to check, it's going to say, do I have a left? So if I check, is there a left of 40? Yes or no? Is there a left of 40? No. So the left part is not there. So I'm done with the left because there is no left. What is going to get displayed first? 40 is going to get displayed first because it does not have a left. So it's going to display itself. Does it have a right? Does 40 has a right? No. So it's also done with the part, right? Now, because 40 is done, the left of 20 is done. So it could say that, yes, my left is done. So now what I'm going to do is going to display myself. So the next data which will get displayed is going to get 20, right? And similar manner, it's going to go on to the right part, which is 50. It does not have a left, it does not have a right, but it has itself, so it's going to get displayed, which is going to be 50. So this whole left subtree is displayed. Because this whole left subtree is displayed, the left for 10 is done. Yes or no? Guys, think about it. Yes or no? The left for 10 is done because the whole, everything which is falling to the left of 10 is done. So what it's going to do, it's going to display itself. So the next data which is going to come up is going to be 10. And then now it's going to go on to the right part. And in the right part, there is no left for 30. So it's done. It's going to get displayed. And then the next thing that it has is right, which definitely is not there. So the output is going to look like 40, 20, 50, 10, 30. Make sense? Guys, does this make sense? What if 40 has a right? If 40 has a right, first the 40 will get displayed because it does not have a left. It's going to get displayed itself. So 40, then the right of 40, then 20, 50, 10, 30. Okay. Yeah? Make sense? Okay. Yeah. Anyone who has any doubt in in-order traversal? Any doubt in in-order traversal, just give me no so that I can explain you in a much better way. Okay, so no means you didn't get it. Okay, if you're clear, just give me clear. And if you didn't get it, just give me no. If you're still in dilemma, if you're still in a doubt, give me a no. Okay, cool. Great. Thanks, Mukesh. Now, let's say I want the pre-order traversal. So let's see how many of you can actually think about the pre-order traversal. Let's think about that. Guys, everyone, just go around and think what could be the pre-order traversal for this particular stuff. Then I'm going to tell you that what the exact output is. Lakshit, just give me 1 second. Let other people do. Then I'm going to explain pre-order, and then we're going to move ahead with the coding part. People says 10, 20, 40, 50, 30. Okay, good. 1030. No. How can it be 1030? It is never right first and then left. No. First you will have to go to the left, then you'll have to go to the right. Just do the LDR in a piece of a paper right next to you will make a lot of sense. 10, 20, 40, 50, 30. Cool, good. Yeah, it's definitely like this. 10, 20. Okay, if you're getting an answer, something like 10, 20, 40, 50, 30, you're right. Right? So it's gonna go like this. First of all, everyone, for the people who have doubt a little bit. So the formula is gonna get changed. The formula right now is going to be DLR. It's going to be DLR, DLR, and DLR everywhere. DLR, DLR, and DLR. See, now it's going to be data. So it's gonna start from here, right? So it's gonna start from here. It's gonna go to 10. Then it's gonna go to the left. Now the left is this, so it's going to get displayed first. So it's going to be 20, then it's going to go to the left, which is 40. But 40 does not have a left, so left is done, the data is done, the left is done, and the right is done, right? So for 20, the left is done. Now it's going to go on to the display to its right, so it's going to be 50. So the left is done, data is done, it does not have a right. Now 20 has done with the data, it's done with the left. Now it's going to go to the right, so the right will get displayed as 30. So the output is going to get 10, 20, 40, 50, 30. Okay, quickly give me the post order so that I can write the code. Quickly give me the post order. Very good, guys. Very good. 40, 50, 20, 30, 10. 40, 50, 20, 30, 10. Cool. Great. Everyone, just this makes sense, right? This makes sense to everyone. Yeah. Okay, cool. Anyone who has any doubt in order, pre-order, and post-order, I hope this makes sense to everyone. Guys, other people, just quickly give me yes. Okay, cool, great. Alrighty then. Okay, if you're ready, we can go around and code this up. Don't worry, I'm going to write code. I'm going to explain everything. Don't worry about that. So should we go ahead and code this app? Cool, great. So what I'm going to do, I'm going to go on to IntelliJ. I'm going to write the display methods. So for display, I'm going to typically going to only sort for 3. I'm not going to go on to level order traversal. It's not the time to go on to level order, though you can definitely go around and do the level order traversal, but right now I'm only going to go on to in order, pre-order, and post order. So first, which I'm going to create is going to be the in order the first thing that I'm going to create is going to be the in order traversal. Okay, now this in order traversal, as I told you, has a small little formula called as left, data, and right. So this is what you actually need to keep in mind before you actually build this in order traversal. Okay, now I'm going to call this in order traversal, or I'm going to create a method out of it. Okay, so in order traversal के लिए एक method बनाते हैं. ठीक है, चलो. This is going to be a public function. I'm going to create a function. For an instance, for right now, I'm going to keep this void, but just definitely it's not going to be void. And I'm going to call this as in order traversal. This is the name of the method. And the method typically takes where to start. So it's going to take node root. It's going to take the root node, and then it's going to do the following stuff. Okay. If let's suppose if you're thinking of to display something up, what could be the bare minimum thing that you'll have to check before you actually go around and display the data? What could be the test cases? If you're displaying something, what could be the test cases that you can think of? Think about it. If you're trying to display something, yeah, cool. If there is data available or not, this is the first thing that you'll have to check. So what I'm going to do, I'm just going to say if root is not equals to null, if it's not equals to null, then I'm going to do something. This means what I'm trying to say, if the data is available, then only I'm going to display, then display. Else just return, right? So I'm just going to say if your root is not equals to null, or you can do the other way around as well, that if root equals null, just return, else do the stuff, right? But this is the easier way of writing this up. So I'm just going to say if root is not equals to null, then perform the display method. Cool. Now what I'm going to do is going to write something really, really weird. A lot of people will get little here and there. That's what is this? But I'm going to explain you this in a little while. Don't worry. Okay. Let me write this up first. I'm just going to say this dot root equals in order traversal for root dot left in order traversal for root dot left. It's giving me an error. I don't know why. Because oh yeah, okay, let it be. And I'm just gonna say system.out.println root dot data. Root dot data. Then I'm just gonna say this dot left equals in order traversal for root dot right. And then at the end, I'm gonna return the root. Okay. Honestly speak, people, how many of you are scared of yeah, I know why it's giving me an error. I know that, I definitely know that. But how many of you are scared of recursion? Be honest. Okay. Okay. You know, when I used to be in my graduation, what's that? Okay, how many of you have no idea what recursion is? Let's start from there. Parv. Anyone else? Just Parv. Anyone else? Okay. How many of you, line 33, this dot root? Oh, sorry. Oh, sorry. This dot root. Thank you. Okay. How many of you knows recursion, but do not know how does recursion works? कहने का मतलब the people who are little scared of recursion. Quickly, just give me a yes or me and stuff like that. Okay, cool. Anyone from the people who are sitting in the session who actually got the code for in-order traversal? Great. Great. Got it. Cool. Now, see, what I'm saying here, just try and understand. What I'm doing is basically creating a function called as in-order traversal, which is going to contain a route. And with that route, it's going to check something up and do the in-order part for you. In case of your in-order, what you actually need to keep in mind if you're doing something like that, it's going to be LDR. LDR, left, data, right. I'm going to perform something if the root is not null, saying if my tree is not empty, then I'm going to do the stuff. I've done the same question in HackerRank. This is not a question, first of all. This is a standard way of displaying something. I'm going to tell you the same question. Abhi question pe aayenge. मैं competitive question करा के जाऊंगा आप लोगों को. Don't worry. So that you will get to know that why this in-order traversal and pre-order and post-order is really, really important. Okay. नहीं यार, हो पाएगा क्या? If we get time, we only have half an hour left. चलो अभी देखते हैं, कोई नहीं, अगर हो जाएगा तो good, नहीं हो पाएगा तो but as of now, what I've done, root null नहीं है, कहने का मतलब you have a tree and the tree basically contains data inside this, so the root is definitely not null. In that case, what I've done, I've said that, hey, listen, I need to go to the left part first, then display my data, then go to the right part. And once I'm done, I'm going to return you with the root. So if the root is getting returned, I'm just going to have to write node up here. Okay. Now, for the people who didn't understand this, it's fine. I'm going to tell you what's happening. Now, see, इसी को यहां लेके चलते हैं, ठीक है? क्या होगा यहाँ पे, अभी देखते हैं इसको. Can I get rid of this? चले एक बार देखें. Should we have a look on the code? I'm going to take a very small little tree for this. I'm just gonna say, let's say, oh sorry, I'm just gonna say, I'm going to say 10, 20, 30, 40. Itna tree will be more than sufficient, I guess. And what I'm doing is basically trying to find out the in-order traversal, right? And what do I have written? I'm just gonna say in order, which takes root. I'm writing a pseudocode, and it checks if root is not null. And if it's not null, I say in order root.left, root.left. Then I do system.out.println root.data, and then I do in order root.right. Now, for the people who have no idea about recursion, I'm telling you a few things about recursion. Just listen to me very carefully. Recursion happens over and over again. Now, what recursion is, first of all, recursion is the case where a function basically tries to call itself. So the name of the function right now here is in order, which is taking a value called as root, which is of the type node, definitely. In this case, what's going to happen? This in order as a function is calling itself over and over again in order to perform something and find the optimal solution out of it, right? Though definitely this is not the optimal solution. The optimal solution is way ahead of the league as of now. But what I'm explaining is this is one of the solutions that you can think of if you're trying to find the in order of any tree, right? What you can do, write this code and this is gonna work. But let's talk about that, how this is going to happen and why have I written the code something like this. Okay. When you write recursion, when you write any code which is a recursive code, one thing that you actually need to keep in mind is every time every element will have the same copy of the same code. ये तो पढ़ा होगा आप लोगों ने कहीं ना कहीं, definitely पढ़ा होगा. that if you're using recursion, the data on which the recursive code is going to get applied will have multiple copies. On every data will have one copy each of the code. Yes or no? Do you know about this? Pata hai, nahi pata hai? Just give me a yes or no. Cool. Now, what happens here is what I'm trying to do. I'm basically starting from here. I'm going to take whole the tree into account and then going to do something, right? What I'm going to do is basically try to perform this. So every data inside this will have a copy of the same 6-line code that I've written out here. So I'm just going to say 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay. Sounds cool. Now, how my code is going to start? My code is going to start from root. Now just try and understand, this is the code which is right in front of you. Then I'm going to say that how it's going to display the data for you, right? It's going to start with the root. In order, root. Right now the value of root is just root, right? It's gonna come here. It's gonna say that if the root is not equals to null, if this is true or not. Is true root null? Is true null? Guys, is root null? This is root 10. Is 10 null? No, it's not null, right? So what it's going to happen, it's going to perform this bunch of code, right? Because definitely root is not null, right? So what's going to happen, it's going to start with L here. This is going to be our L, there is going to be D, and there is going to be R, right? So what it's going to do, it's going to trigger one more function inside this. But right now, the code for this data 10 is still lying here. It's not completed. It's still under process. But because it's still under process, what's going to happen? Because it has left, it's going to call the function called as inorder root.left. Got it? And what will get triggered is basically the left of the root, which is basically root this node 20. And this 20 itself has some bunch of code which it needs to execute before it's done. What does it has? It has LDR inside the same code, right? And now this code base, everywhere there is written root, will get changed to root.left. Why? Because the parameter that you have passed for this function is root.left. So jahan pe you are seeing root, that root will get replaced to root.left. Now, if I say if, so the function which is called is inorder root.left, and what it's going to check is if root.left is equals to null. Is 20 null? So root.left is 20 because 10 ka left is 20. So if I ask you, is root.left null? No. 20 is definitely not null. Yeah. Guys, yahan tak clear hai? Yahan tak clear hai? Just give me yes or no. Okay. Now, what's going to happen? It's coming up here. The root.left is not null. So again, it's going to execute this 3 bunch of code. And here, what it's going to pass is in order root.left. And the value of root is what? Root.left already. And it's going to append one more dot left to the same. This is going to look like root.left.left. So the function which got triggered initially was root. Then it got converted to root.left. Now the function which is getting called is in order of root.left.left. Okay. And again, it's going to come here and say if root.left.left is null, is 40 null? Guys, is 40 null? No, 40 is not null. And this is still under process because the left of this particular stuff is still not completed. And now it's going to check to this part and it's going to say this 40 is not null. So it's going to again perform these 3 lines of code. But now it's going to call one more function called as in order. And in order mein root ki jo value thi, that root value was root.left.left, and it's going to append one more left to it, which is going to be dot left. Now, if you just check the value of root.left.left.left, is it available? No, it's not available. It's null. So what's happening that in order of root.left.left.left, this is null. So the left is null. So it does not get executed. So it's going to come here. What is going to get executed? The system.out.println root.data. What is going to get displayed now? Guys, think about it. What will get displayed? The D part. And this D is going to display what? It's going to display 40. So this is done. Now it's going to come up here and it's going to say, right, do you have something called as root.left.left.right? No. So this will also not get executed, right? Because the 40 is executed, the left for 20 is executed. Now what it's going to do, it's going to come here and display itself, which is going to be 20. And now it's going to go to the right. So it's going to be root.left.right. Is there anything called as root.left.right? No. So this is also executed. Because this is executed, the left part for 10 is executed. And now it's going to execute this D part, which is going to be your 10. And then it's going to switch to the right part. And the right will have 30, which contains LDR. So now the function call which will get made is going to be in order root.right. That's what is happening. The system.out.println is done. Now the in order root.right. So root.right. So if I check if root.right equals to null, is 30 null? Is 30 null? No. So all the 3 line of code will get executed. First, it's going to come to left. Is there anything called as root.right.left? No. So this will not get executed. Then it's going to display itself, which is going to be 30. It's got executed. Is there anything called as root.right.right? No. Right? So this is also executed. So this is how your whole recursion is happening. Now, does this make sense? Does this make sense now? How to trace the previous data? How to trace the previous data? Very simple. When one node complete, okay, anyone who has idea about stack memory and heap memory? Stack memory, heap memory ke bare mein, anyone who has idea? Right? So what happens with every function call? If we ever get time, if we ever have a session like over again, we can talk about stack and heap memory. This is really, really important as a concept for any programming language that you go around with. Yeah, it's push and pop. And every recursion call basically is making use of your stack memory, right? So usme hota kya hai? Every time you're calling a function, it will get piled on in your stack memory until and unless it's completed. So backtracking in case of your recursion only happens just because of stack. And every time you make a wrong recursive call, you get an error called a stack overflow. You might have seen that up. So if you use wrong recursion, it gives you an error called a stack overflow. This is just because it uses stack memory in the background. Yes, guys. एक बार उसको run करके देखें. We can run that code and we can verify that what's happening behind the scenes. Shall we? Guys, shall we? उस code को complete कर लेते हैं and then we can see what could be done, है ना? So let's say, okay, so this is what I've created and I'm calling this as an in-order traversal. But if you just have a look on this, this is taking and returning a value called as node. And this is also asking for root every time. Abhi data ruk jao. It's fine. I'm going to make the data. Don't worry. Abhi sab kuch hoga. I'm going to tell you how you're going to create this tree. Now, if you just have a look on the traversal, this traversal is always asking you for a root, right? And what do we have? We have a global variable called as root, which is basically needed to be passed to this. So humko bar root ko pass karne ki zarurat nahi hai. So what I'm going to do is going to create an encapsulated code for the same. So this is going to be encapsulated code. And this encapsulated code is going to look something like this. I'm just going to call this public void in order. and this in order is not going to take anything. And in turn, this in order is going to call this function called as in order traversal, and I'm going to pass the root, and I'm going to say in order traversal of the root. Does this make sense? So what I've done is basically encapsulated up your whole code. Okay, guys, is it okay? So this is encapsulation which I'm doing right now here, right? And then what I'm going to do is going to create the driver class or the driver method, which is going to be a main method. This is going to be a main method. So what I'm going to do is PSVM, which is public static void main. And in this main, I'm going to build the tree. Now, everyone just pay attention. Everyone is here? Guys, is everyone here? Cool. Now, what I'm going to do, and this is where the difference between the binary tree and BST comes into picture. And there were few people who were having few doubts. Now I'm going to resolve all your doubts. Now what I'm going to do is going to build a tree, whatever kind of like a tree which I want, right? Typically, the structure of the tree depends on me, that how I'm going to create the tree for myself. So what I'm going to do, that inside the main method, I'm going to build a tree for myself. How? Let's have a look. So what I'm going to do, first of all, I'm going to create the object for your binary search tree, which is this. Oh, sorry, binary tree, which is this. So what I'm going to do is going to come here. I'm going to say binary tree. I'm going to call this tree equals new binary tree. Now just have a look, guys. Abhi, thodi der pehle we were discussing that anytime I'm going to create the object for your binary tree, what is going to happen? This constructor will get called. Where it's getting called? This is the constructor which is getting called. And when this constructor will get called, automatically the value for your root is going to be null, right? So the moment you create the object, your root is initialized to null. Make sense? Guys, does this make sense? So the moment I created binary tree, the moment I created the object for binary tree, the root is reset to default, which is null. Yes? No? Guys, yes or no? Cool? Okay. Now what I'm going to do, I'm going to say tree, which is the object which I've created. I'm going to say tree dot root equals new node. I'm going to pass 10. Just see what I'm doing. I'm saying, hey, I've created a tree. This tree has a root, which right now is null because it's default, because that's what your constructor is doing for you. So I've kept it default as of now. The root is going to be null. And now what I'm doing is basically initializing the root to the first node, which is 10. Okay. And then what I'm going to do is going to create and build the whole tree. Now, which I'm going to say that tree dot root dot left is going to be a new node, which is going to be, let's say 20. Then I have tree dot root dot right, which again is a new node, which is, let's say 30. And also I can do something like tree dot right. Oh, sorry, tree dot root dot right, let's say dot left equals new node. And let's say I pass it with 40. Okay. Now just figure this out, what I'm trying to explain you up here. Ye kiya hai maine, just figure this out. Just have a look on the main method and just give me yes or no if you are having doubts anywhere. Guys, make sense? Now what I'm doing is building up a tree depending upon how I want this tree to be. Now for the people who are saying that we have formula for trees like n, 2n plus 1, 2n plus 2, does this hold for binary tree? Think about it. It does not hold for binary tree, but yes, this holds for binary search tree. If we ever get time, if we meet ever again, we're going to talk about binary search tree in the next session if we have any. But this is how you're going to cater onto your binary tree. This is your binary tree. It does not have any formula. This is really random. This is really, really random. Okay. And then what I'm going to do, I'm just going to say tree dot in order. Right. Let's go ahead and run this up if this works or not. This typically should work, but if we get an error, we can have a look on that. So this is the output. So the output is 20, 10, 40, 30. How? Let's see. What we have done and what the kind of like the tree that we built was, I guess हम लोगों ने सबसे पहले बनाया था 10, then left was 20, 30. So this is how it used to look like: 10, 20, 30. And then what we have done was root.right.left. So root.right.left had 40. So this is how your tree was looking like, right? So this was the root. So in order is going to be what? The first data. Okay, just have this tree and tell me the in order, everyone, in the chat section privately. Nobody is going to text publicly, just give me privately. What is the in order traversal for this particular tree which I've created in the main method? This tree that you see, give me the in order for this tree. Good. LDR, yeah, in order, LDR. Good. So the output is going to be what? No, Ayushi, no. Kunsh, no. Yeah. Arvind has given me wrong. Arvind, just have a look. Arvind, this is wrong. Rest, all the people are right. So what's going to happen? LDR. So the leftmost will get displayed first, which is going to be 20. Then the parent of 20, which is 10. Then it's going to come to the right. And here it's going to be LDR. So first the left of 30 is going to get displayed, which is going to be 40, then 30, right? So the output is going to be 20, 10, 40, 30. 20, 10, 40, 30. So this is what we're getting as an output. So we can assume that yes, that's what we have implemented and we have implemented it right. I just hope this makes sense to everyone. Yeah, guys. Okay. Now the same stuff you could do with pre-order and post-order as well. Really easy. Or rather, what I'm going to do is going to copy this whole app. I'm going to paste it twice. I'm going to say there is nothing hard and fast which is needed to be changed if you want to work with different traversals. So what I'm going to do, I'm just going to call this in order. This is typically your pre-order traversal. I'm gonna say pre-order traversal. Pre-order traversal. But in case of your pre-order traversal, your display happens before left and right. Okay. So this is what we have done. Pre-order traversal. Right. So this is what I've done. In case of your post-order traversal, this is going to look something like this. It's going to be post-order traversal. This is also going to be post-order traversal, and the display is going to be at the end because that's what we have learned. Okay, so this is LRD, this is DLR, and this is LDR, right? And then we can also create encapsulated methods for the same. So yeah, Aishi yours was right. So what I'm going to do is going to create pre-order traversal. I'm going to call pre-order traversal. Similar is the case with post-order traversal. Here I'm going to create the encapsulated method for post-order traversal. And you can go around and call these methods up again. And I'm going to say, let's say I want to see tree dot pre-order and then tree dot post-order. So tell me what is going to be. So the in order came out to be as 20, 10, 40, and 30, if I'm not wrong. So tell me the pre-order for this tree. इस ट्री के लिए प्री ऑर्डर क्या होगा? Tell me. Think about this and give me the answer. Other people? Okay. Okay. So if I'm not wrong, the pre-order, if I'm wrong, correct me out. The in order is going to be, I guess, 10, 20, 30, 40, if I'm not wrong. Yeah? 10, 20, 30, 40? Cool. And if I talk about the post order, the post order is going to be what? The post order. Mm, 20, 10, 40, 30. Mm-hmm. Other people? 20, 30, 40, 10. Okay, let's go around and have a look. So this is the tree. And what do we want to do is basically L, D, no, L, R, D. Okay. So first we're going to go onto the left. So the left is this. So first 20 will get displayed. Then we're going to go onto the rightmost part. Then it's going to be 40. Then it's going to be 30. And then it's going to be 10 if I'm not wrong. 20, 40, 30, 10. Yeah, 20, 40, 30, 10. Yeah, it's going to be 20, 40, 30, 10. So let's go around and run this up and let's see if we have made the assumptions right or not. And then I guess it's 10, 20, 30, 40 and 20, 40, 30, 10. Yeah, got it? So this is how you make a binary tree happen if you're working on any programming language that you want. So the concept remains the same for any programming language that you're working on. So the concept is going to be the same. Can we get the code? Definitely you can get the code. I'm going to send this code to CipherSchools, and you can ask CipherSchools to get the code from you. Okay. Or I'll just push it up on GitHub and then give you the repo and stuff like that. Okay, so we didn't get time to actually start on with BST. I was thinking if I can tell you something about BST, but I hope that you enjoyed on with the session. We actually are running short on time. So we have 10 minutes. You're from LPU. No, I'm not from LPU, but I have taught LPU. No, I'm not from LPU. I am from IIT Bombay. Well, I was from IIT Bombay. I have taught LPU. So okay, so anything that you want to ask, like related to anything. Now I'm open to questions. Is there any crash course on data structures? First of all, there is no crash course for data structures. To be very honest, there is no crash course for data structures. Thank you so much, Vani. Thank you so much. Okay, so there is no crash course for data structures. The reason you do not have a crash course for data structures is because this is completely mind games that you play around with people. Don't go for crash course. That yeah. DSA versus web development. See, even if you go into web development, you'll have to learn DSA. That is for sure. Because JavaScript, okay, how many of you have a little bit of a knowledge about JavaScript? Okay, so for the people who would understand this, if somebody is working on JavaScript, you again have higher order array methods. Is there any lecture on data structures taught by you? I'll have to search. I'm not sure about this, Farman, but you can read. Okay, for the people who have doubts or might be a situation I won't be able to solve out your doubts, maybe what you can do is you can go on to LinkedIn. You can connect with me on LinkedIn. Yeah, that's what I'm saying. You can go around and you can connect to me on LinkedIn. So this is how my LinkedIn looks like. Okay, you just go around and search for me with my name. This is my name, Arun Kudyal. You can go around and search for me, and most probably this would be the profile that pops up, right? So if you will have any doubts, you have to ask for suggestions. You have to ask for anything related to right now, related to future, related to how to get into Fang and stuff like this. We can have a discussion about that. But this is the whole picture. Okay, so shoot me up with the questions. So if you're talking about first question is data structures versus web development. So for the people who knows web development, if you talk about JavaScript, you have higher order array methods like map, filter, for each and stuff like this, which again requires few things you should be really familiar about with data structures and data types and stuff like this. So I'll highly recommend learn the scratch from data structures. Even if you don't go into programming or dynamic programming or competitive programming and stuff like that, but basic knowledge of data structures is really important for any coder, right? Web development is right now on boom. because of MERN and mean stack, if somebody knows about that, either you can go with React or you can go with Angular. And anyone who is interested, premium messages pops up. Mostly use data structures or algo. Mm, Mostly use data structures or algo. Algo. I'll go with algo. So basically what happens, conscious, that you design up an algorithm, then you implement that algorithm using data structures. So this is what happens. Might be a situation you come out to be such a great a person which you can think of one algorithm or could create a new data structure. Anything could happen, right? So you should have knowledge both ways, algo as well as, even if you create an algo, what are you going to do with that algorithm? Think about it. You'll have to implement it somehow, right? Even if you think about it, you think that, okay, fine, I'm going to travel from my place to my friend's place, and then I'm going to do this, then I'm going to do that. Makes okay, but yeah, Apple India, correct. Apple India. Yeah. Anything that you want to ask, that how we can get into the FANG, or what should we do? Is it true that Apple employees get 20% discount for the perk? We get more than 25% for any Apple products. But if you're thinking that you could ask me for Apple products, so I'm extremely sorry, I cannot do that. It's fine. Yeah, I get a lot of discounts on Apple products. That's true. But yeah, maybe if you would had been my friend, I would have helped you out. Kidding. Anyways, any other questions that you have? Any other questions that you have? If Anurag is here, if we have any questions on YouTube, we can question that up. I am a beginner. But think about this. Everyone is a beginner. But the problem here is, how much time do you invest as a coder? That is really, really important. Sources to strengthen DSA. Highly recommended. Go around with HackerRank and HackerEarth, enroll yourself into that, and just start practicing. The more you practice, you know what? Data structure is exactly like maths. The more you practice, the more you're fluent with this. And I'll tell you what. I'll tell you what. How many of you are still stuck at programming languages like कि क्या चुनूं, क्या नहीं चुनूं, क्या कैसे करना चाहिए, कैसे नहीं करना चाहिए? How many of you are like कि what programming language I should select? How to get into Apple? Good question. I'm going to talk about that at the end. Anyone who's stuck with the programming language कि यार क्या select करूं या क्या करूं? See, I'll tell you what. Go with two programming languages that I highly recommend, because that's what I've done as for now. If you're good with C and C++, select any other object-oriented programming. The reason I'm saying you like this, because you have an idea about both the world, right? Because if you talk about C and C++, which is object-structured programming language, it's not object-oriented. It does support few object-oriented concepts, but not purely object-oriented. Go around with a programming language which is completely object-oriented, like Java, Python, JavaScript, any of the other object-oriented programming. Plus, keep C and C++ in your hand, because this how to get internship in FANG. I'm going to come out with this. I hope this makes sense. So select C, C++, or Objective-C, plus along with that any other object-oriented program, and try to implement data structures and algorithm in both the dimensions, in object-oriented programming as well, and in C and C++ as well. Sir, who can become an iOS developer? If you're good with Objective-C, you can be an iOS developer. So iOS development uses Objective-C, Swift, and Swift UIs. You would be an iOS developer. Even if you know Flutter here and there, or even React Native, you can do iOS development. Which data structures to use most? इसका कोई आंसर नहीं है, because it depends on the problem statement. So we were about to discuss कि कब क्या use करना चाहिए, but we didn't have time. So I'm extremely sorry. I would have loved to answer that, but it's a long, lengthy answer. But I cannot give you the exact. Confused to start learning C and Python. C and Python is a good combination, but I'll highly recommend if you go around with C++ and Java, because वहाँ पे you will get a lot of similarities. Which all languages you suggest? Any two? C++ and Java, with here and there of JavaScript if you're into web development. Dynamic programming. One more session. We can talk to Anurag sir. Anurag sir, we can plan on doing sessions and stuff like that. Why not Python? Python, I'll highly recommend to those people who are into machine learning and data science and stuff like that. Got it. So if you are into data science, machine learning, these kind of like stuff, Python is good for you. In second year, if it's no second, okay. How many of you are from second year? Data science ML people select Python. How many of you are from second year? Cool, great. For second year people, this is like the golden time that you have. Trust me, if I would had been so much aware in second year, I would had been in a leap year ahead. Matlab, like I opened up my eyes when I was in third year, and it was already late. Right? Second year people, data structures तो तुम ऐसा कर लो कि nobody can ask you like anything apart from data structure. I'm not talking about competitive programming, I'm just talking about data structure. मतलब if somebody is asking you, let's say I want to create a key value pair, you should be like चलो यार hash maps use करते हैं, चलो ऐसे करते हैं, right? So even if you're in first year and second year, first and second year people, you have such a beautiful time right now. Dictionary, exactly. Hash maps and hash sets are exactly the same in case of your Java. So if you're working on data structures and algorithm, this is the best time for you to learn data structures, right? Jaga jaga mat bhago. Just stick to two programming languages, implement the whole data structures and algorithm in those two programming languages. Select C++ and Java, you will get a lot of similarities between the same, right? So these are two beautiful languages that you can learn. If you want to go into mobile development as well, so Android uses Java and iOS uses Objective-C. So you'll be good on both the backgrounds. And learning along with the development, if it's good or not. Yes, it's definitely good. You get a hands-on onto what practical scenarios that you can think of. If you're into development, definitely learning and development makes a good combination. Learning web development, mean stack, Mern stack. Okay. So if you want to get into Facebook and stuff, Mern stack is a good stack that you should get on, or any of the web development framework as for that. If you want to get into, you could say, if you want to go around with into Google and stuff like that, you should know Mean, because Angular is basically Google's and React is basically Facebook's, right? So if you want to get into Facebook and stuff, you can definitely can go with Mern stack. If you want to get into Google, I'll highly recommend you go with Mean stack. Though Mern is more famous than Mean, I'm not saying famous, but both the applications can do good, right? So it's nothing hard and fast. Any other questions that we have? Ask. This is the good time. You can ask. I'll be more than happy. Even if it takes 5 to 10 minutes more, it's fine by me. At least I'll answer up your doubts if you have any. See, मैं तुम्हें एक पता है एक बहुत छोटी सी बात बताऊं. Take 6, I'll not say 6 months, around take 6 to 7 months. Learn data structures अच्छे से. I have a book. Okay, have you seen that book? White color की book है. And it has leaves. I forgot the author, but it's a standard book. It's a very standard book. Let me think. Let me search. Let me search. Just give me 1 second. Algorithms book. And this is a very, मतलब मैंने अपना literally अपना पूरा BTech and अपना पूरा it's the third edition book of Corman and Thomas. Corman and Thomas की एक book है. It's a very standard book. Yeah, Corman. So Corman की it's a very standard. It's a little thick book, so don't get scared कि ये क्या है. But it contains anything and everything. Even if you're a pro developer or even if you're a beginner, that book, just wow book, like literally wow book. How to study it? I tried. How to? Okay, so you didn't get anything out of it, Akshat? No. Okay. Okay, where are you in, Akshat? Okay, for the people who are in first year and second year, इसको तो ना ही पढ़े तो बेहतर है आप लोगों के लिए. हाँ, third year में वो तो आप you might have come across with ADA, analysis and design of algorithms. I hope you have this, right? So उसमें everything is done, yeah. Everything is given कि how you do big O, small o, mega, theta, everything is all there. So if you just read, okay, first thing, read line by line this book is really one heavy book, which is really standard everywhere. If it's come to India, US, any of the other book, first year and second year, there is a book called as Dennis Ritchie. It's written by Dennis Ritchie, and there is a book called as C Language. I'll highly recommend you go around with that because it's gonna give you a very good foundation on C and C++. It's a very standard book. It's written by the person who has designed C and C++, right? But like, yeah, what I'll tell you is sit with a reference. Sit with a reference. Even if it's Google, Stack Overflow and Google is the best companion for any developer. This is really, I'm being really frank. Even me being into one of the Fortune companies, I still Google around with soft copy of this book. Maybe if I get, I'm going to give you the link. मैं देख लूंगा एक बार. You can connect to me on LinkedIn. If I get the soft copy, I'm definitely going to put it on my Google Drive and give you a link. Okay, if that could be done. GFG is good for DSA? No, don't go for GFG. GFG is, or maybe you could say Stack Overflow and stuff like this. Don't go with the all. See, pata hai kya, Jayesh? These are pro people. They know how to take a shortcut. And what typically happens, you try to copy their shortcut, but sometimes in the long run you get behind. Okay, so what really happened was yesterday I was listening onto your conversation where you were saying कि Java करें या Kotlin करें या ऐसे कैसे कर सकते हैं and stuff like this. See, I'll tell you what. Kotlin is great, but okay, anyone who has any idea about JavaScript and jQuery? किसी को थोड़ा बहुत idea? See, JavaScript and jQuery does the same stuff, but again, जो आपका vanilla JavaScript है, that is way more efficient as compared to your jQuery. jQuery is used for really high standard stuff. So is the case with Kotlin. Kotlin में जबरदस्ती just सुन रहे हो कि Kotlin, so just don't go and jump onto Kotlin. First and understand the basics of Java. Until and unless आपको Java के बारे, okay, how many of you actually know about Maven? Anyone who has any idea about Maven? Maven or Spring Boot and stuff like that? No. See, that's the problem. You are saying you're going to write everything in Kotlin where you have no idea about what Maven is and how. Okay, if you're a good, it's not a framework. It's definitely not a framework. It's not a framework. Yeah, Spring and Spring Boot it's something with Java, but it's real. Maven is something. It's not a framework. Maven is not a framework. Maven is basically a library that you can use. There are so many APIs. Google, Guava. You have web APIs. You can connect to the database. You can apply JPA and stuff like this. You can do everything that you want in Java, and you can basically create enterprise applications out of it. But I do not see any point just because you have heard about Kotlin and you think about migrating onto Kotlin. पहले Java तो पढ़ो. Video lectures of GFG is from basics. See, Jayesh, it's good but not good. Reason GFG is not good for longer run. This is what I've seen. This is my experience that I'm talking about. GFG is not good for long run commute. उसमें होता क्या है, everything that you see or everything which is being taught or everything which is being talked is given to, okay Jayesh, one small little question. Okay, do you follow the fact which is written on Wikipedia page? Just think about it this way. जो भी कुछ Wikipedia में लिखा है, is it true? No. Same is the case with GFG. If you just go around onto Geeks for Geeks, उसमें आप देखोगे this code is contributed by somebody. Getting my point? What I'm saying now, that somebody has a complete different perspective. Okay, fine, yeah, this is how I'm going to talk about one small little problem statement. But Jayesh, कर पा रहे हो? Don't go with, how should I explain it? Guys, see, take okay, Akshat. No, see, take global scenario. Okay, how many, okay, Jayesh and Akshat, do you want to go into FAN? Do you want to go into FAN? So you have to talk in the same manner where you see, okay, how many of you do not know about FAN? Okay, so FANG basically shorts for Facebook, Apple, Amazon, Netflix, and Google. These are some prime companies or fortune companies that we talk about. कि Amazon में जाना है, Apple में जाना है, Google में जाना है, यहाँ काम करना है, वहाँ काम करना है. These are called as FANG. So if you're targeting FANG, just see that worldwide people apply there, right? They apply there, and you have to be on a benchmark where you can talk standard. You cannot talk, you cannot talk nonsense in front of them, and you be like कि, अरे भैया ये तो मैंने geeks और geeks से पढ़ा है, right? So this is not going to make a good impression on the other people. Study what everyone is studying, take standard things into account and then study. Why am I saying that Dennis Ritchie को पढ़ो? मैं ये भी बोल सकता हूँ आपको कि go and study, what is that person's name? I forgot his name. एक Let Us See करके एक book है, उन्होंने लिखी है. I don't know the author. And I don't know why students are crazy about Let Us See and Let Us C++ and stuff. Guys, see, try and understand. Dennis Ritchie was a person who made C and C++, right? He'd be knowing more about the programming language. So why not study standard books where you see that, yes, this knowledge is actually tested and done and all of that stuff. Okay, for the people who are thinking कि Apple में कैसे जाना है, so go to apple.com. How complex should I go into data structures and algorithm? Don't go too much into it. Because competitive programming is where you have to give your 100%. Like if you're good with competitive programming, trust me, even if it's Apple, even if it's Google, even if it's FANG or any fortune company that you can think of, you're good to go. If I should learn through various courses and books, or just start with, go with courses, no problem with the courses, but again, use your brains. Don't just bluntly follow anyone. Just use your brains and then do the stuff. I completed all the basic, but the complex structures always come like okay. So Param, I'll highly recommend you stick to one programming language and then do the competitive programming part. If you're good with data structures, go with the competitive programming part. Okay, so this is what I'm doing. Just give me one little second. So what I've done, I have this website, which you call, this is apple.com/in. Cybersecurity graduates at Apple. Really, rarely, like very less, very less. So if you're gonna scroll down up here, what you're gonna see is, or either I'm just gonna tell you one small little thing. What you can do is basically go around here and say jobs.apple.com. This is my LinkedIn profile, guys. This is my LinkedIn profile. Just type Arun Kodiyar and most probably you're gonna see my face out there. Okay, so if you go into jobs.apple.com, so here, if you just scroll down and you can get started, you can create your own profile out there. Everything is like self-explanatory. You do not need to do anything with that. Even for Netflix, I'm just gonna speak the same because I got selected in Netflix as well. So it's fine if I okay. So it's gonna ask for my Apple ID as of now, but this is the whole picture. Just go to jobs. Okay, so I'm just gonna drop this up. So once is jobs dot apple.com, and then there is something called as jobs.netflix.com. You can go around and apply there after second year for internship, after third year for full-on placements, right? So I got selected in the end of the third year of my BTech, right? So you can apply out there. If you're good with data structures, you are good with any fan company. Okay. Any other questions that you have? Any other questions? Even if you suck at web development, it's fine. See, the only thing that they need is I put a problem in front of someone and someone comes out with the code. That's it. If you can do that, you're good to go with FANG. Trust me. Can only BTech students? No, I myself am an MTech student, so I'm an MTech graduate. So no, it's not mandatory that only BTech people can apply. Even EC, BTech can do, BE can do, any of the things could do. The only thing that उनको डिग्री से भी मतलब नहीं है. If they give you a problem statement, you can code, you're good to go with FANG. That's it. I'm in third year, just knowing the basics. How could I improve profoundly? Go with HackerRank and HackerEarth, subscribe there, make an account, take competitions, code those competitions, you're good to go. Because of you went to MTech, I got placed first at Byju's, and there I worked for around for a year. And once I was done with final year, then I went to Apple. worked there for a year, then pursued on my gate, then I gave my gate, and then I did my MTech like distance while working, and then I'm here. So you can plan your career any which ways that you want. The only thing that I'll suggest, that don't waste your years. That's it. Don't waste your years. That's really, really important. Okay, so any other questions? We are already 15 minutes late. Can you tell me step by step round that we have? Okay, for people, I'm really sorry to cut you up, Akshat. For the people who, this is really late because it's more than 2 point, yeah, 2 घंटे से ऊपर हो चुका है ना, 2 घंटा से भी okay. So this supposedly was to be kept till 1.5 घंटे का lecture होना था, but we have kept it for बहुत long. So I'm just gonna cut this short. For the any people who have any doubts related to anything that you wanna ask, feel free to push your DMs on my LinkedIn. I'll be more than happy to help you up. You can DM me, we can have a chat, we can talk about what your problems are. Okay, don't worry about that. Cool. So I just hope that you enjoyed the session. Rest, I'm just gonna call out to Anurag. If Anurag, can you hear me up? Okay, how many of you actually enjoyed the session? Be honest with this. So somebody be like, sir, pata nahi sir, aapne bahut pakaya aaj. Chalo. I just hope Anurag is here. I'm just gonna hand it out to Anurag. Thank you so much for the people who enjoyed the session. I'm more than happy that you actually learned something out of it. But I have more questions in mind. It's fine. You can push your any doubts that you have on my LinkedIn. I'll be more than happy to help you. Are, it's my pleasure. Anurag, can you hear me? Anurag or Vani, somebody.
Yes, sir.
Hi,
Thank you
hi.
so much for the session. It was really great one. Even I enjoyed the session so well.
Oh, thank you
You
so
know,
much.
it was
So
really
this was it from my side. I'm just gonna leave the session. Rest, Vani is up there for you. Thank you so much for joining. I hope that you enjoyed the session, and most probably we'll be meeting sometime soon. So bye bye from my side. Bye bye, Vani. Bye bye, guys.
thank you, sir.
Bye bye.
Thank you so much, everyone, for joining. It was really great having you all. And stay tuned for the upcoming sessions. And thank you so much. Here we go. I just read your message, Paramveer. We sure will organize one very soon. Stay updated, and you guys can leave. Thank you so much. Catch you all tomorrow.